thank you everyone for joining us for another week of Lightning Talks. If this is your first time, welcome. Happy to see you here. Lightning Talks happen here at In Rhythm every week, 5:15 p.m. Eastern on Thursdays. It is a place for our practice area consultants to come together, teach back to the community on something that they're either working with on their day-to-day basis, or like Raphael, this is something he's really passionate about. He sees the world of cloud computing moving into the space, has done a little bit of research and wants to share the research back with the team here. So super special Lightning Talk. I'm really excited for it. Format for the Lightning Talk today is we are going to start with a poll, just to kind of gauge our audience. Again, I know a few of you may not be working with Function as a Service. That's totally fine. That means you have lots and lots to learn, like me, during today's Lightning Talk. So we're going to figure out, get a gauge of the room, see where everyone is with Function as a Service. And then we will hand things over to Raphael. He's going to teach us some of the things that he's been learning, and then we'll leave room for question and answer at the end. So with that being said, let's get started with the poll. Really easy one. What's your experience with Function as a Service? You work with it, you've dabbled with it, you've heard of it, or you have no idea what FAAS is, or better known as Function as a Service. Oh, we got one person working with it. That's awesome.
Yeah, it's really good.
Who is that one person?
Probably Raphael.
Victor, you're working with it? Awesome. All right, so
yes,
just to share.
Using Quizlet from Google.
Okay, awesome. So just to share results quickly, we have Victor, who's currently working with it. Awesome. We have a couple people who've dabbled with it, a few people who have heard of it, and then the other majority of the folks who have no idea what FAAS is. So with that being said, I'm going to hand it over to you, Raphael. Everyone's excited to learn, and let's get the party started.
So according to the poll now, I dabbed in it, but I was at 38%. That what is FAAS? So it's a concept we can grab. Like staying cutting edge for the computing solutions, the cloud solution. So we have Function as a Service. So the what, why, and how, and that's kind of the generalization of all the technologies you can go into. The what is it, why you use it, and then how you actually use the new technology. In this case, it's this Function as a Service. So thank you for joining today. So we go, what is FAAS, Function as a Service? So it's serviceless computing. So FAAS is a category of cloud computing services that provide a platform allowing the customer to develop, run, and manage application functionalities without the complexities of building, maintaining the infrastructure typically associated with developing and launching an app. As you can see in this diagram, you can see, and in this image, you can see that in the legacy infrastructure, you have the server, security, transaction management, schedule, and more. And it all resides within the app. And you see Faas, you actually see just the function itself. So even from this high level diagram of this image, you can see how much is under, as we call the iceberg, and only the surface of what you see is actually the function itself. And then we go more into one of the concepts that I really like about the Faas is the event-driven services computing. So Faas is it can be an event-driven serverless computing platform that can also solve complex orchestration problems, build and debug locally without additional setup, deploy and operate at a scale in the cloud, and integrate services using triggers and binding. And then you see an example in one of the, we'll talk about it later, one of the vendor solutions for this Faas is the Aws Lambda. And then here's an example of how you can use event-driven approaches with Lambda. And you see you have DynamoDB here, streams, which is essentially, say, if you create a user, you update a user, you can create these streams more like triggers within the DynamoDB database. And then with those streams, you can actually trigger Lambda functions to perform different actions within that stream itself, within that trigger itself, and then that's within the Lambda. So you can see this is data events, and it's driven by the streams, but then it's actually can be aggregated to Lambda function. So here's an example of how event-driven service computing can be done with Faas. And then we go into the why I use Faas, which is, okay, a lot of technology out here. So why use, what's the benefit? So let's dive into the benefits of actually using functions as a service. So obviously any development, any development environment, development shop, any software development, it's always a cost associated with it, right? So with Faas, it's pay as you go. So you pay only when an action occurs. When the action is done, everything stops. No code runs, no server idles, no costs are incurred. And you can see from this traditional deployment approach, you see the inconsistent traffic pattern, and you can see the traditional deployment concept. So here you see requests per second, and you can see here it peaks, right? Here it peaks at 200 requests per second. You see it also peaks again at 200 requests per second. Now, how do you, in a traditional environment, you have to have the servers available, you have to have required resources available to accommodate those peaks. In this case, it'll be 200 requests per second. But if you look at the bottom, you have all this idle time that occurs. But still, you still have to pay the cost for those peak moments within the request. So the pay-as-you-go model allows you don't pay for those downtimes, right? When the requests are not being made. So in this part, you're not paying for actually using the resources because you're not actually using the resources. And then you obviously pay for these request times and peak times when requests are actually made. So pay-as-you-go is a really good model. I mean, obviously, so whatever, based on the type of function, in this case, we use function as a service, and then you only pay for it actually when you use it. Another great concept, great benefit I see from Faas is the auto scaling. So the auto scaling to scale functions, and it's scaling individual functions also, and the pay-as-you-go is individual functions. So you can look at it as a suite of functions and a microservice. You have a microservice that has n number of functions, but then each function is scaled independently. Obviously, it says pay independently. So the ability to scale functions automatically, instantaneously, and independently whenever required. So you can go to a typical week, we have, as, development and applications run, every day, right? So we have Sunday, days of the week, Sunday through Saturday. And you can see the different capacity peaks that occur. And then we have two different situations, right? You can set the capacity to low capacity to actually take on the averages, or more or less the lower half of the capacity load. But then you see sometimes it could be over capacity, right? So now you see Wednesday, Tuesday, and Monday, it's over capacity, and then now you haven't allocated enough capacity to handle those peak days. And then another example, so now you say, okay, now I need to obviously cover those over capacity because you don't want any hogging the resources, you don't want the application to be down, any slowness for the user or the consumer of the application. So at this point, you see, okay, now we peaked it to the highest performance level, which is on Wednesday. But now you see the unused capacity here, and it goes back to you actually allocating more than actually needed for, say, even for Saturday, which is a really unused capacity level here. But if you go to the Faas and the benefits of Faas, with the auto scaling, you can see the auto scaling adjusts the capacity as needed. And you can see this red line goes along as the days of the week goes, and it scales the capacity according to what's actually the capacity that's needed. And then another one of the big components of the big why for Faas is the focus on the code, not the infrastructure. So you can divide the service, like I said, microservices into functions that can be scaled, as we talk, scale automatically and independently, so you do not have to manage the infrastructure. And this allows you to focus on the app code and can dramatically reduce the time to market, and just get, just me understanding fast. AWS is, obviously one of the big players in force this computing solution, and they have a lot of case examples of companies using it and speeding up their time to market, reducing it dramatically. And I'll go over some of the backend as a service approaches. And it's kind of, as you can see, it's kind of progressed over time, right? As we evolve and as we more understand, kind of like the patterns of what applications need, the consistency of what applications need. So we'll start with the infrastructure as a service. So the green is actually the vendor. The vendor implement, manages, creates these boxes in here in the infrastructure as a service. You can see the vendor is actually the one maintaining and creating and scaling that area. And then how you see the operation system. So and with this infrastructure as a service, you see the developer or the team or the company will have to manage, create, security, all those different monitoring, run the operating system, runtime, application, and functions. And as we go up, we see platform as a service. So now it's better, right? So we see 3 green boxes the vendor actually takes it care of. And then now a developer or the organization is only having to deal with the application and the function. I really like this graph, but there's one more that you can say is the container as a service. And then for the container as a service, it'll actually be the vendor be actually maintaining the infrastructure, operating system, the runtime, and the container scaling up and down, which we see more modern these days with Kubernetes and Docker image. But then we take it one step above and say, okay, I just want to, like you said, I just want to focus on the app code. None of the infrastructure. Let me get the implementation done. I know what needs to be done. I know the business logic that needs to be executed. So I only want to create the functions. And then you can see from the vendor standpoint, now they say, okay, I will handle, maintain, create the infrastructure, the operating system, the runtime, and even the application itself. And we show an example of how AWS uses with Lambda and actually allows you to specify the application use itself. And then you only have to, at this point, you only have to implement and develop it within the function layer itself. So that was covering one of the 3. It's a lot of whys, right? But this is one of the ones that I felt worth talking about, and one of the most important when it comes to software development and just development in general and practices. So stop, any questions?
I just got to say that roll of thunder really made your lightning talk. Took it to the next level.
Oh yeah, I'm seeing lightning.
I was thinking the same thing.
Lightning is coming down earlier from the sky, so it's a lightning talk.
Okay. Any quick questions for Raphael? No? All right.
So we go to the most important, right? So now we have the what, the why, and then the how, right? So any knowledge, it needs to be applied. So let's go into the how to use Faas. So Faas, so this is so it's made by different vendors. So we have the Faas. So Faas was initially offered by various startups circulating around 2010, such as PyCloud. So 11 years that has actually been around, but obviously technology, we have, advanced, companies or startups that actually push forth the effort. And then as usual, the big tech companies jump on board later on. So you see IBM has their cloud solutions, cloud functions solution. Microsoft, Aws Lambda that we'll talk about, Google Cloud Functions, and we actually I think this is part of Apache. So they have the open Faas open source solution, and then Oracle also has that. And here are the 3 major or the most popular, most utilized solutions for Faas is AWS Lambda, Azure Functions, and Google Cloud Functions. So we would dive into the most popular one. A lot of people obviously going towards AWS. So we go into Amazon solution implementation for Faas. So AWS Lambda by Amazon. So let's start here. So the use case at the bottom, this is pulled from the AWS Lambda website. So the use case at the bottom, you can see you can use it for data processing, real-time file processing, real-time streaming processing, machine learning, web applications, which we'll have an example after this slide about how a very simplistic example of web applications, IoT, IoT backends, which is getting really popular, and obviously mobile backends is getting really popular. And this is more of a general representation of how the Lambda, I guess you could say, flow architecture works. You see, you upload your code to AWS Lambda, or you can write code in the Lambda code editor. And then you can set up your code to trigger from other other AWS services. You can do HTTP endpoints, traditional endpoints, or in any in-app activities. And then from there, you have the Lambda run your code only when triggered. And it all goes only when triggered, right? Event-driven. And then using only compute resources needed. And then the main benefit, right, is just to pay for the compute time you use. So at this moment, I'll go into actually some examples within AWS Lambda, so you can get kind of like get a concept of how the tooling works within AWS Lambda, and then just what's available, and just kind of get some familiarity around the AWS Lambda solution for Faas. So I'll exit here. I actually have one more slide here. And then here's I don't know if you should be able to share the deck, but here's an example use of a web application. And this is a full scale web application that is actually available in this GitHub repo. So as you learn, you can, it's very intense. It has this very scalable, actually a lot of functions used within this example. And then here, this is the most common usage of functions. You see, we have the Amazon S3. This can have the front end code. And then as regular web applications occur, user clicks. And in this case, example, user clicks to get the local weather information. And then from here, this is the key aspect. A lot of times when you're dealing with the web applications with Lambda, is that you have this Amazon API gateway. And then this is a router. So this is exposed, API gateway is exposed. It's exposing an endpoint to the users. And then within internally, it knows the resource. In this case, the resource for the API gateway is actually the Lambda itself. And the Lambda will run code to retrieve, in this case, local weather information from the DynamoDB and return data back to the user. And then you have the last aspect here, which is the DynamoDB. So this is additional web application and the flow from web application and how AWS Lambda is involved within this new architecture within Faas. Okay. So we'll go to the, so this is the AWS. So yeah, this is AWS services. So I've created two examples here. So you go to Lambda and you go to functions. Like I said, this is a really simplistic approach, but obviously you have to start somewhere, right? And then eventually then you go to the point of, full scale uses of Lambda and functions and having this microservice actually implemented in a functional way. Using not just AWS, but there's a lot of vendors. Just this AWS is the most popular. And just to kind of get a sense of the interface within using creating functions. Like I said, it's a lot of tutorials out there. Google it. Amazon provides a lot of documentation. They have the free tier available. So there's a lot of areas where you can have a playground to actually get comfortable and more familiar with the Faas function as a service. So just to highlight some of the dashboard and functionality of AWS, you can see the create. So you have a couple of options. This is one of them that I use, is to get familiar with the hello world, right? We all know the hello world just from 101 computer science course. So, and then you have use a blueprint, which I will go into with actually a microservice here that I've created. So you can see here they have a lot of options. This is the one I use, the HTTP endpoint, but they have a lot of different starter projects where you can start getting familiar with how it's used, the response time, and this whole paradigm of Faas. And then you can use container images. So you can have your function in a container image. You can have it in the ECR and the Elastic Container repository, and you can reference it here. And then this is also another, I thought this was really cool. You can kind of sort through some of the serverless application repository. And I actually wanted to use this one. So they asked Alexa skills. So Alexa, every time, I use Alexa. I know a lot of people probably use Alexa too. And every time you use Alexa, that's using Lambda. That's using function as a service. So that's a real world example of how responsive, how quickly this software paradigm within computing, cloud computing solutions can be utilized. So every time every time Alexa, you say, hey Alexa, why is the weather in New York terrible today? That's a function as a service application in Lambda. So, and then so let me go back to functions. Like I said, this is the Java one, most of Java. Then I've created this microservice example for Node.js. And then so when you're at this point, you will see the function itself, and then you see the API gateway. And as we talked about, and like you can go through yourself, but it's really, a click a couple buttons here, there, and okay, I want to focus on the function itself. But as you can see, it has created the monitoring. So now you have the monitoring, CloudWatch is specific to the login for AWS. You have the logs, you have the configuration, which is in this case the API gateway. You actually have the security. So I picked the most simplistic one, which is the API key. And then you can see here, it spun up the API gateway. It used the function name, and this is the exposed external API endpoint. And then the resource itself path within the API gateway is actually the function name itself. And then you can see this is the function here. And you can see the code here, and they only have, we're hardcore developers. We don't have to have this code editor here, but they do supply a code editor for Node.js. And then you can see the code editor here. And this is real, like I said, a CRUD operation. This has delete, get, post, put operation with a DynamoDB. And then here's some of the syntax for the actually Node.js. Like I said, you can use Java. They have, let me go back. They have, go back to a couple of you can see a couple of languages they have. So they have Node.js, they have .NET, Go, Java, Python, and Ruby. So once you have your function ready in those languages, you go straight to the code. Straight to the code here. So I have Postman here. I just wanted just to have it in real life action. I'm going to make a call in the Postman to the endpoint, like I said, the core operations, and you see I've created a DynamoDB database. Really simple, just ID name for demo purposes only, and I will go to the Postman. So here you see again, you see the API gateway endpoint. You see the path here. The last path for the endpoint is actually the method itself. And then this is a low-level native API call to DynamoDB, which applies the table name here, as you see. And then you pass in the item and then the different information here. So I'm creating another record, ID2, with name Sally. So right. So you see, create the record. You have update, delete, and retrieve. So let's go back to the DynamoDB database. Let's do a refresh, and you see Sally has been in it. So, and that in that point, you see this request has been made. It goes to the API gateway. The API gateway knows what resource to call, and this is this function here. So, you can imagine this in scale functions. You can have 100 different functions, right? They might take X amount of time, or, some, might be more computational intensive, where you have running for some time. You really just have all the flexibility. I would say, before I just give the last part of the demo, I would say that one of the, like I said, not so good benefits, right, is that it is stateless, right? So it's no state, in memory state. But that's essentially how all microservices are these days, right? We're making is it event driven? You make an action, you perform some operation. You might retrieve the database, or you might reroute to another function. And then as you can go back to the monitoring, as in all created within the creation of this function. You can see, let's go to the last hour. It's 10:40. What time do we have? Yeah, so we can see the 38 minutes. And this is the log watch. So obviously you can put logs and any logging information you have, and then you can actually see that by default they give you the build duration in milliseconds, memory in MB, build duration JB seconds. So you can see this was run for 167 milliseconds, and then also created for you automatically is you can see the duration. Here you can see this is the 100. I think this might be the one. Yeah, so this you can see the duration, the error count, success rate, and a lot of metrics. You like I said, you get out of the box all those metrics, monitoring, logging, and then the only thing that was actually done on the developers end was to actually create this method. That's it. Any questions?